Unlock the secrets of the universe, a journey into the unknown. For centuries, humanity has grappled with profound questions: why are we here? What's it all about? While definitive answers remain elusive, recent scientific advancements have significantly deepened our understanding of the universe and the continuous evolution of life within it. This journey into the cosmos and consciousness is a testament to our relentless pursuit of knowledge and the mysteries that still await discovery. The quest for understanding. Human curiosity about the universe has driven countless scientific inquiries and discoveries. Our quest to comprehend the cosmos has led to breakthroughs that challenge our perceptions of reality. From the intricacies of quantum mechanics to the vast expanse of space, each discovery unveils a new layer of understanding, pushing the boundaries of what we know and what we can imagine. Disproving mystical phenomena. One intriguing aspect of scientific exploration is debunking myths and misconceptions. For example, the likelihood of telepathy and levitation has been rigorously examined, and scientific evidence strongly suggests these phenomena do not exist. This process of demystification not only clarifies our understanding of the natural world but also reinforces the importance of empirical evidence and critical thinking in distinguishing fact from fiction. Evolution of critical thinking. The evolution of life from sea to land is a fascinating chapter in our history. As life forms transitioned from aquatic environments to terrestrial habitats, they developed critical thinking abilities essential for survival. This cognitive leap enabled more complex behaviors and adaptations, setting the stage for the development of higher intelligence and consciousness. Understanding this evolutionary process provides insights into the development of human cognition and our place in the natural world. The concept of entropy. Entropy, a fundamental concept in thermodynamics, plays a crucial role in understanding the universe's behavior. It refers to the measure of disorder or randomness in a system. High entropy indicates a state of greater disorder, while low entropy signifies order and structure. This concept helps explain various natural processes, from the mixing of milk and coffee to the life cycle of stars. Recognizing the significance of entropy enhances our comprehension of the underlying principles that govern the universe. Implications for the future. As we continue to explore the nature of time, space, and consciousness, the implications for our future are profound. Scientific advancements offer potential solutions to some of humanity's greatest challenges, from energy sustainability to medical breakthroughs. By expanding our knowledge and embracing new technologies, we can create a future that harnesses the power of scientific discovery for the betterment of all. Embracing the journey. In this era of rapid technological and scientific progress, it's crucial to remain curious and open-minded. The journey to understand the universe is ongoing, and each discovery brings us closer to unraveling the mysteries of existence. As we delve deeper into these topics, let's appreciate the incredible strides we've made and look forward to the possibilities that lie ahead. Thank you for joining me on this exploration of the universe's inner workings. If you found this content enlightening, please like, share, and subscribe to spread the knowledge. Together, we can transform curiosity into wisdom and continue our quest for understanding. The physics of reality, understanding our world and debunking pseudoscience. Humanity has long sought to explain the natural phenomena around us. In ancient times, our ancestors attributed these events to the whims of all-powerful gods. Today, however, physicists use the scientific method and the laws of physics to understand what causes the sun to shine and the rain to fall, providing us with a much clearer picture of the world. This approach also allows scientists to debunk many of the paranormal phenomena that continue to capture the public's imagination. The core theory, a framework for understanding the universe. Frank Wilczek, a physicist and Nobel laureate, introduced the term core theory to describe the fundamental laws of our universe. The core theory encompasses the interactions between known particles, such as quarks, electrons, and neutrinos, and the forces that affect them, including electromagnetism, gravity, and nuclear forces. It also includes the Higgs field, an energy field that gives particles their mass. This theory provides a comprehensive framework for understanding how these particles and forces govern the universe. Practical applications of the core theory. While there are limitations to what the core theory can explain, it covers almost everything that affects our daily lives. It explains the interactions between light molecules and atoms or entire objects, and how these interactions allow a hummingbird to hover in mid-air. By understanding these fundamental principles, scientists can develop technologies and solutions that improve our quality of life and expand our knowledge of the universe. Debunking pseudoscience with physics. One of the valuable tools within the core theory is crossing symmetry, which helps rule out many phenomena found in popular science fiction, such as telekinesis and telepathy. For instance, telekinesis, the supposed ability to move objects with the mind, would require a particle that the mind can produce or manipulate to interact with matter. Let's call this hypothetical particle particle X. The non-existence of particle X. According to crossing symmetry, if particle X existed, it would be created during proton-antiproton collisions. However, extensive experiments studying these collisions have found no evidence of particle X, even under extreme conditions. This lack of evidence effectively rules out the possibility of telekinesis. The same process applies to other paranormal powers, such as telepathy and levitation, further demonstrating that these phenomena are not supported by the laws of physics. The scientific method and rational inquiry. The scientific method relies on observation, experimentation, and logical reasoning to build and refine our understanding of the world. By adhering to this method, scientists can separate fact from fiction and provide explanations grounded in empirical evidence. This approach not only debunks pseudoscience but also encourages a rational and critical way of thinking that is essential for scientific progress and innovation. Rethinking causality, a new perspective on the universe. We are all familiar with the concept of causality, the principle that every action has a cause and effect. This idea has been central to the development of modern science and philosophy. However, recent debates among physicists and philosophers suggest that causality might not be as fundamental as we once thought. This new perspective challenges long-held beliefs and invites us to reconsider our understanding of how the universe operates. Aristotle's influence on causality. The importance of causality can be traced back to Aristotle, who firmly believed that every movement was caused by something else. He used the example of a book on a table, which remains in place unless moved by an external force. Aristotle extended this reasoning to the entire universe, proposing the existence of an unmoved mover, an entity that initiates motion without itself being moved. For Aristotle, this unmoved mover was akin to God, setting the cosmos in motion. The shift in modern physics. Modern physicists, however, have begun to see flaws in Aristotle's argument. They view causality as less crucial to our fundamental understanding of the universe. One significant reason for this shift is the nature of space. Consider an object in space isolated from any friction or external forces. According to the law of conservation of momentum, this object will remain in motion indefinitely, demonstrating that continuous motion does not require a cause. The Enlightenment and Laplace's contribution. The idea that cause is unnecessary isn't entirely new. During the French Enlightenment, astronomer Pierre-Simon Laplace dismissed the need for cause and effect, favoring observable patterns instead. Laplace illustrated his point using the example of billiard balls. When one ball strikes another, it transfers motion. If we reverse this action, as if rewinding a film, the motion still adheres to the laws of physics. This reversibility suggests that causality is not fundamental, rather, the laws of physics govern motion. Implications for understanding the universe. Laplace's insight implies that if we can describe an action using the same formula in both forward and reverse directions, causality is not a necessary component. Instead, the laws of physics themselves dictate the behavior of objects. This challenges the traditional view that every effect must have a cause and opens up new ways of thinking about the universe. A new framework for science and philosophy. As we continue to explore the universe, this evolving perspective on causality invites us to develop new frameworks in science and philosophy. By focusing on the underlying laws and patterns rather than cause and effect, we may uncover deeper insights into the nature of reality. This shift not only enhances our understanding but also encourages innovative approaches to solving complex problems. By questioning the fundamental role of causality, we embark on a journey that could transform our view of the universe and our place within it. The dual perspectives of fundamental and emergent theories. The abandonment of causality has profoundly shaken the scientific community, leading to a fundamental re-evaluation of how we understand the universe. This shift has resulted in the emergence of two distinct perspectives, the fundamental, microscopic level and the emergent, macroscopic level. These viewpoints offer different insights depending on the situation at hand. Understanding the fundamental level. To grasp the difference between these two perspectives, consider a room filled with gas. At the fundamental level, the gas is simply a collection of rapidly moving molecules colliding with each other. This microscopic view allows for precise descriptions of each molecule's velocity and orientation. It's a detailed, granular perspective that focuses on individual particles and their interactions. The emergent level perspective. In contrast, the emergent level provides a macroscopic view. Here, The gas is seen as a fluid with properties such as pressure, temperature, and density. These properties are not evident when focusing solely on the microscopic level. The emergent perspective is valuable for understanding the collective behavior of particles and how they come together to form a cohesive whole. Choosing the right perspective. Both fundamental and emergent perspectives have their advantages, and the challenge lies in choosing the appropriate one for the problem at hand. Each perspective comes with its own set of vocabularies and concepts, and neither is inherently superior or truer than the other. Their utility depends on the specific context and the nature of the inquiry. When to use the fundamental perspective. If you are examining a region with very few molecules and need to understand their individual behaviors, the fundamental perspective is most effective. It provides the tools necessary for detailed analysis at the microscopic level, allowing for precise measurements and descriptions of particle interactions. The utility of the emergent perspective. On the other hand, when dealing with a large number of molecules and aiming to describe their collective interactions, the emergent perspective is more useful. It helps to understand the overall behavior of the system and the macroscopic properties that arise from the interactions of numerous particles. This perspective is particularly valuable in fields like thermodynamics and fluid dynamics. The concept of emergence in understanding time. The concept of emergence has significantly contributed to our understanding of various phenomena, including time. By shifting our focus from the microscopic to the macroscopic level, we can gain new insights into how complex systems evolve and interact. This dual approach allows us to tackle a wide range of scientific questions, providing a more comprehensive understanding of the universe. By exploring both fundamental and emergent theories, we can appreciate the complexity of the natural world and develop more effective strategies for scientific inquiry. This balanced approach not only enriches our knowledge but also enhances our ability to address real-world challenges. Time's arrow and the role of entropy. Time, as we perceive it, progresses from the past to the future in a linear fashion, largely due to the concept of entropy. According to the laws of physics, events can occur equally well in reverse as they do forward, which raises the intriguing question, why do we experience time moving only in one direction? The fundamental view of time. From a fundamental viewpoint, time is symmetric. Imagine a billiard ball experiment by Laplace. If you were to reverse the motion of the balls, the actions would still align perfectly with the laws of physics. The same symmetry applies to atoms colliding, pendulums swinging, or planets orbiting. Fundamentally, time does not favor one direction over another. The macroscopic view of time. In contrast, our macroscopic experience of time is asymmetric. We remember the past but not the future, and we age progressively from youth to old age. This macroscopic perspective of time aligns with our everyday experiences, highlighting a clear direction from past to future. Entropy and time's asymmetry. The concept of entropy explains this asymmetry. Entropy measures the disorder or randomness within a system, and as a fundamental law, it always increases over time. Our own aging process exemplifies this. We grow older, our bodies weaken, and ultimately, we die. This increase in entropy is a one-way process, unlike the reversible billiard ball experiment. Observations of entropy in nature. Empirical observations consistently confirm that entropy increases over time. There are far more possible states of high entropy, disorder, than low entropy, order. For instance, sand is more likely to be scattered randomly than meticulously shaped into a sandcastle. This overwhelming likelihood of increasing disorder underpins our linear experience of time. Complexity amidst increasing entropy. While entropy generally increases, leading to more disorder, certain systems, such as galaxies and living organisms, become more complex and organized over time. This apparent contradiction invites further exploration into the nuanced behaviors of entropy and complexity in the universe. Exploring the complexity paradox. The increase in entropy, which drives the arrow of time, does not preclude the emergence of complex and organized systems. Understanding how complexity arises amidst the inexorable march of entropy can offer deeper insights into the fundamental nature of the universe and life itself. By understanding these concepts, we gain a clearer picture of why we experience time as a one-way journey and how the principles of entropy shape our world. The exploration of time, entropy, and complexity continues to challenge and expand our understanding of the universe. The emergence of complexity from entropy. If increased entropy leads to more disorder, it seems counterintuitive that complex and organized structures could evolve over time. However, the relationship between entropy and complexity is not straightforward, and it is precisely this nuanced interaction that allows complexity to arise. Nonlinear relationship between entropy and complexity. The relationship between entropy and complexity is best visualized as a curved line. At either end of this curve, the system is simple, but in the middle, complexity peaks. This can be illustrated by observing what happens when milk is poured into coffee. Initially, the two liquids remain separate. Over time, they blend into a homogeneous mixture. However, during the mixing process, a period of intricate swirls and patterns emerges, representing a highly complex system. The universe's journey from simplicity to complexity. The universe itself follows a similar pattern. Just before the Big Bang, the universe was in a state of low entropy, hot, dense, and simple. Over billions of years, entropy has steadily increased, leading to the formation of complex structures like galaxies, stars, and planets. Eventually, the universe will return to simplicity as entropy reaches its maximum, and all matter dissipates into a state of uniformity. Complexity amidst rising entropy. Currently, we live in a period where the universe is teeming with complexity. This includes not just celestial bodies but also intricate forms of life. The gradual increase in entropy over time has led to the natural emergence of these complex systems. For example, the swirling formation of our galaxy is a direct result of entropy's influence. Entropy's role in biological complexity. Understanding how entropy contributes to biological complexity is more challenging. While it's easy to see how rising entropy can create the swirling arms of a galaxy, it's harder to envision how it can lead to the intricate structures of living organisms. However, just like the milk and coffee example, the process of life and evolution can be seen as part of the universe's journey through a phase of peak complexity. The natural order of complexity. Life forms, including humans, are part of this intricate dance of entropy and complexity. The increase in entropy doesn't just lead to chaos, it also creates the conditions for complexity and diversity. This dynamic interplay between disorder and structure is a fundamental characteristic of our universe. Embracing the complexity of life. The universe's current state of complexity, with its myriad of living organisms and celestial structures, is a testament to the beautiful interplay between entropy and order. Understanding this relationship helps us appreciate the intricate balance that shapes everything from galaxies to life on Earth. In sum, the rise of complexity amidst increasing entropy is a testament to the intricate and fascinating nature of our universe. By exploring these concepts, we gain a deeper appreciation for the delicate balance that underlies the cosmos. It's intriguing how entropy, often associated with disorder and randomness, plays a fundamental role in the creation and evolution of life on Earth. Michael Russell's provocative theory posits that life itself is a vehicle for increasing entropy on our planet. This theory hinges on the biochemical processes of early life forms, which metabolized carbon dioxide and hydrogen to produce methane and water, compounds with higher entropy than their precursors. Essentially, life's emergence can be seen as a natural consequence of Earth seeking to increase its overall entropy, a principle deeply rooted in thermodynamics. Russell's insights have been bolstered by subsequent discoveries, such as the confirmation of underwater hydrothermal vents in 2000, which he predicted would provide the ideal conditions for early life. These vents, rich in chemical energy, likely served as cradles for the first organisms, fostering conditions conducive to the emergence of life's earliest forms. As life evolved from simple organisms to more complex ones, the mechanism of natural selection, proposed by Charles Darwin, became paramount. Natural selection acts upon genetic variation within populations, favoring traits that enhance survival and reproduction in specific environments. This evolutionary process explains how organisms, like giraffes with their long necks, adapt to their surroundings over generations, optimizing their chances of survival by accessing resources otherwise out of reach. However, the evolution of intelligent life poses a deeper question: how did complex traits, like cognition and consciousness, emerge through evolutionary processes? These traits, which distinguish humans and other intelligent species, hint at a progression beyond mere survival mechanisms. Exploring the development of these advanced traits provides a fascinating glimpse into the evolutionary journey that has culminated in beings capable of self-awareness, creativity, and complex social interactions. In the upcoming discussion, we will delve deeper into the complexities of intelligence and consciousness, exploring how these remarkable features emerged through the interplay of genetic inheritance, environmental pressures, and the ongoing quest for adaptation and survival in an ever-changing world. Understanding consciousness remains one of the profound mysteries of human existence, yet scientists are optimistic about unraveling its secrets. The evolution of consciousness, according to bioengineer Malcolm McIver, took a significant leap forward with the transition of species from sea to land. This shift provided organisms with enhanced sensory capabilities, allowing them to perceive distant threats and strategize accordingly. This development marked the beginnings of cognitive processes, critical thinking, and the ability to imagine different outcomes, a pivotal stage in the emergence of consciousness as we understand it today. Contrary to historical philosophical views that posit the mind as a separate, immaterial entity distinct from the physical body, contemporary scientific inquiry suggests a more integrated approach. The concept of dualism, championed by thinkers like René Descartes, has faced scrutiny due to its inability to explain how an immaterial mind interacts with a physical brain. Descartes himself struggled to provide a coherent explanation for this interaction, pointing to the pineal gland without elaborating on its mechanism. Modern scientific methods and advancements offer a different perspective, emphasizing the interconnectedness of mind and body. Rather than viewing consciousness as something wholly separate, contemporary research explores how physical processes within the brain give rise to subjective experiences. This approach aligns with the scientific endeavor to uncover the neural correlates of consciousness, identifying specific brain activities and structures associated with conscious perception, cognition, and self-awareness. While the exact mechanisms of how atoms and neural networks generate consciousness remain elusive, the scientific community remains hopeful that continued research and technological advancements will shed light on this profound phenomenon. The quest to understand consciousness represents not only a scientific challenge but also a philosophical and existential inquiry into what it means to be human. As our understanding of brain function and consciousness evolves, so too does our appreciation of the complexities that define our conscious experience in the universe. In delving into the depths of modern scientific inquiry, we've embarked on a journey that has illuminated both the known and the enigmatic. Through the lens of physics, we've gained profound insights into the mechanics governing our universe, from the orbital dance of planets to the intricate web of forces shaping our everyday existence. This exploration hasn't merely affirmed the laws that govern our physical reality, it has also debunked fantastical notions like telekinesis, revealing them as mere flights of fancy in the face of rigorous scientific scrutiny. Yet, beyond dispelling myths, our journey has unearthed deeper truths about timeless questions that have perplexed humanity for centuries. By applying scientific rigor, we've begun unraveling the mysteries of time itself, understanding it not as a linear progression but as a dynamic interplay influenced by entropy and cosmic evolution. This nuanced understanding challenges our perceptions, inviting us to reconsider how we perceive order, complexity, and the unfolding of existence itself. Central to our exploration has been the quest to understand consciousness, a phenomenon at the heart of human experience. Through scientific inquiry, we've moved beyond traditional dualistic views of the mind, exploring how intricate neural processes might give rise to consciousness. This endeavor promises to illuminate the depths of our cognitive abilities and subjective experiences, offering glimpses into the inner workings of the human psyche that have long eluded clear explanation. As we navigate these frontiers of knowledge, we are reminded of the profound impact of scientific thinking on our understanding of the universe and ourselves. It is through curiosity, skepticism, and empirical investigation that we continue to expand the boundaries of what we know. Each discovery, each insight, brings us closer to unraveling the complexities of existence, shedding light on the fundamental questions that define our existence and our place in the cosmos. To those who have joined us on this intellectual odyssey, I extend my heartfelt appreciation. Your curiosity fuels our exploration, and your engagement enriches our collective understanding. By sharing this journey with your loved ones, you amplify the reach of knowledge and inspire others to embrace the wonders of scientific inquiry. Together, we embark on a quest for truth, guided by the belief that through understanding, we empower ourselves to navigate the complexities of our world with clarity and purpose. In the words of Albert Einstein, the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. Let us continue to embrace the beauty of discovery, to explore the mysteries that surround us, and to celebrate the journey of knowledge that unites us all. If you haven't already, please consider subscribing to further explore the wonders of science and deepen our understanding of the universe and ourselves. Together, let's continue to uncover the secrets of existence and marvel at the infinite possibilities that await us.